Students, this is called the area and probability. Make sure you get a date, time, and location for each of these videos. Probability. Geometric probability is the mathematical probability expressed as a percent that a point will be in a certain region compared to another region as related to specifically area and volume. That word compared implies a fraction. So it's going to be a certain region compared to another region. And as a fraction, you're going to translate that into a percent. This will make sense in just a moment. Put your finger right here. Let's read this out loud. Find the geometric probability that a point would be in the shaded region of the image below compared to the entire shape, which is a square. So we're being implied that this shape is a square. So you come over here, and so first we're going to find the area of the entire square. So the entire square, of course, is going to be 12 times 12, side squared, 12 squared. Of course, that's 144 units squared. So here, the area of the whole is 144 units squared. The shaded region, you could either do it like this, where you do what's called negative space. You find the area of the whole thing. You find the area of this, and then you subtract. That's called negative space. You can see it that way. Or you can do what's called positive space, where we just see each of these individually and we add them together. Really doesn't matter which way you go. Okay, because I have two of the same thing, I am simply going to find the area of 1 and times it by 2. So it's a right triangle, and in a right triangle it's leg times leg over 2. So in this case, one leg is 6. The other leg, of course, is going to be 12. So 6 times 12 over 2. And then, so that gets you one triangle. And then we're going to times by 2 because we have 2 of them. So when you multiply this out, those 2's are going to cancel. So we're basically doing 6 times 12. Of course, you get 72. So the area of our shaded region is 72 units squared. So the question here is being asked, what is the percent probability that a point will be in the shaded region compared to the whole? So we're asking, what's the percent probability that a point will be somewhere in this shaded region compared to the whole? So the area of the shaded region is 72. The area of our whole is 144. Of course, you divide that. We made this rather easy. You should be able to see that that's exactly half. So that gives us, there is a 50% probability that a point will be in the shaded region compared to the whole. Find the area of the shaded region. The inside shape is a rhombus. Each vertex is 1.5 inches from the side. So 1.5 inches, we go like this. 1.5 inches all the way around. So we want to find the area of the potential, which in this case is going to be this shaded region. That's what we want. Now to get that, we're going to be doing the area of the rectangle minus the area of the rhombus. Area of a rectangle is length times width. The rhombus is diagonal times diagonal over 2. Watch very carefully. Our length, trace it, always trace, guys. Always physically trace. Width, physically trace. Now we physically trace here. One diagonal. You're like, wait a minute, there's nothing there. Let's take a close look at this. I'd like you to put your fingers, like thumb and forefinger, right where those X's are. Pinch that. Okay, you should see the distance between that, if you bring it down, is 10. Now we're going to go in 1.5, in 1.5. So this diagonal here is 10 minus 3 is 7. So I have one diagonal is 7. Going this way, if you put your finger here and here, pinch it, you can see that distance is 6. And we go in 1.5, in 1.5. That means this diagonal here is 3. So one diagonal is 7, the other diagonal is 3 over 2. That's 21 divided by 2. It's 10.5. So the area of the shaded region is 60 minus 10.5. That means the area of our shaded region is 49.5 units squared. The area of our whole is 60 units squared. We get 0.825. So it is approximately an 83% chance that a point will land in the shaded region, an 83% chance, compared to the entire area. This page you get to do completely on your own. Pause the video, restart to check your work. Find the probability that we're in the shaded region compared to the entire square. So first off, to get the shaded region, we are doing square minus 4 circles. Square is side squared minus 4 times pi r squared. The trick to this is this 6 comes right down here, which means our diameters are going to be 3 and 3, which means my radius, is what I need, is 1.5 squared times pi times 4. My side squared is 6 squared. So 1.5 squared times pi times 4. That gets us 28.27. This, of course, is 36. We subtract. So our shaded area is approximately 7.7. Now to get the percent probability that a point will be in the shaded region compared to the entire circle, that's going to be 7.7 divided by the whole region, which is 36. and we get approximately a 22% chance. Actually, I think it was 21. Let's double check that. 21.3, yes, so we're going to call that at 2120, 1.213, etc. So it's approximately a 21% chance that a point will land in the shaded region compared to the whole. Check your work. Write a note of reflection.